Hi everyone, this is Hitesh and welcome to another interesting video where we will learn about the coroutines in Kotlin. So by the end of this video, you will learn or you will get a solid understanding of coroutines, how, when and where to use them. So before we understand what is coroutines or before we get into the definition, we should understand that how the application works. So whenever the user launches the application, right, a main thread is created by default on which any kind of operations happens. So assuming this is our application, and since we have launched it, a main thread is already created, and assume that we are trying to operate a few operations which are lighter operations for sure, like button click or the UI interactions, smaller operations or small logical operations. So this is how it works. But what happens if you have to perform some heavy operations on the same thread, like the main thread, like for example, the long operations or the network operations, an API call, or you're trying to fetch the images or you're trying to download the file. So what's going to happen if these kind of operations you have to do on the main thread? Usually you might have seen that if we do so, we end up with ANR error, right? The app not responding, because whenever any kind of heavy operations is getting performed on the main thread, or when the main thread is not responding, the application doesn't respond for more than 5 seconds, then we end up seeing an error called ANR, Android not responding. So I would suggest, or I believe that it would be a bad idea to perform heavy operations on the main thread. But if that is the case, if you're not going to perform these operations on the main thread, then on which thread we should be doing these operations? So the answer is we can create a background thread, or we call a worker thread, which is not the main thread but is created from the main thread, and it helps to perform heavy operations. So this will be a main thread which will be having the smaller operations, the light operations, and then this will be a worker thread which will have the longer operations or the heavy operations. So for each operation you would have to create an individual thread, like for long operations thread 1, network operations thread 2, image loading thread 3, and similarly thread 4. So these are just the 4 operations, assuming you have n number of hundreds of heavy operations that you want to perform on the application. So of course you would have to create hundreds of threads to perform all of these operations, right? To execute all of these functions. But if we do so, then again we will end up with one more error, and which would be out of memory exception. Of course, because there is a limited memory that happens or that has been allocated to the application, and if you try to perform thousands of operations at the same time by creating thousands of threads, then you are definitely going to end up with this kind of exception. So this is also again not a good idea to create different threads. So to rescue this issue, the coroutines comes into picture. So how it will work is, assuming we will create a one background thread, other than the main thread we will create one single background thread, and on top of that thread we will launch multiple coroutines, like coroutine 1 it will perform this operation, coroutine 2 it will perform this operation, coroutine 3 it will help in image loading, and coroutine 4 file loading, and vice versa. And that's how it happens. So be it 4 operations or be it 100 operations, there will be only one single thread that will be running on other than the main thread, and those all the operations will be executed using the coroutines. So what are coroutines? We have to understand that. Co stands for cooperative, routine stands for function. The functions that cooperates with each other are called coroutines. These are lightweight threads. Like threads, coroutines can run in parallel, wait for each other, and they can communicate with each other. But they are not threads. They are not the replacement of threads. They are not equals to threads. Coroutines are very cheap, almost free. We can create thousands of them without any issue of the memory. And the coroutines are best for the modern applications, because in today's applications we can see a lot of operations that works around on the same application. We may have to upload, we may have to download, we may have to make an API call, and a lot of other things happen. So for all of those things we don't have to create thousands of threads. We can just create one single thread, background thread, and we can execute all of these operations. So coroutines are the best place we can make use of them. Now when or where to use coroutines. So let's take an example of function A and function B, and there is a when case for both of them. The cases are taking integer as a parameter. So if case 1, 2, 3 or 4, any of the cases happens, we are going to perform some task A1 and then we will call function B, which is this one. Again for 2, we will, so for the moment we call function B, it will go here, and if the case 1 happens, we will perform some task again B1 and then we will call function A. Now we have passed as case as 2, so it is going to execute this section. Similarly, it will go from here to here and then it will execute this and then it will be passed to function B of case 3, similarly for 4 and similarly for 4 of function A. So this is how it's gonna work. And with Kotlin coroutines, this above cooperation, right, can be done very easily, which is without the use case of when or switch case, which I've used in this example for the sake of understanding. I mean, we actually don't have to make use of switch cases or the when cases when we are making use of coroutines. It is just for the sake of understanding how it's going to help or how it is going to execute when we are making use of coroutines for the similar kind of operations. So, now that we have understood that what are coroutines and when it comes to cooperation between the functions, so there are endless possibilities that open up because of the cooperative nature of the functions. A few of the possibilities could be, it can execute function A, few lines of function A, and then it will pass on to function B, and then again a few lines of function A, and so on. So this will be helpful when a thread is sitting idle and not doing anything. In that case, it can execute a few lines of another functions. So this way it can take full advantage of the thread. Ultimately, cooperation helps in multitasking. It will be enable writing asynchronous code in a synchronous way. So if you can see that, right, this is how it's gonna help. Now there is a use case where we actually make use of the coroutines, and the use case says that assuming we are making an API call, fetch and show user. So first we are going to fetch the user from the API, and once we have received the information, we will show it on the main thread. So this is how we are going to launch the coroutine. So guys, we will talk about the launching modes, the dispatchers and everything in the next video in detail. For individual topics we'll take. For now, just try to understand how the coroutine will be helpful in such a case. So it is going to make an API call for fetch user, which is going to happen on the input output thread, that is the background thread. So assuming we have came here, and then we'll make the network call on the IO thread, and once we have received it, we will return the user. So once the user is received in this function, it will go on the main thread and it will show on the UI. So that's how it is going to work. There will be two things that will happen. One is going and working on the background thread, and the second one coming back on the main thread and showing or loading the user. So coroutines, as I've mentioned earlier, it is not the replacement of threads. It's more like a framework to manage them. So the exact definition of coroutines would be a framework to manage concurrency in a more performant and simple way with its lightweight thread, which is written on top of the actual threading framework to get the most out of it by taking the advantage of cooperating nature of the functions. So guys, that's all about the coroutines. This is how it works, and this is just the basic understanding about what are coroutines and what is the purpose of coroutines and how different they are from the actual threads and how they can be used and how they can be executed. So in the next video, we will be taking individual topics for in detail to understand about suspending functions, the dispatchers, how to start a coroutine, and what are the different type of scopes. So all four of them are the part of coroutine series itself. These are these things are used at some of the other places when we are making use of coroutines, and we will take them, each one of them, as an individual video, as an individual topic to understand in details. So now the conclusion is we know what are coroutines and when to use them, And if you have found this video helpful, please don't forget to like, share, comment, and subscribe to my channel. If you have any specific questions related to coroutines or any other topic you would like me to cover in future videos, feel free to drop a suggestion in the comments. I would be more than happy to create more content for you. Happy learning, and I'll see you in the next video. Thank you.